Also taken from the end of chapter exercise in the Siavula textbook of chapter 6. Okay, this is a question from exercise 6.2. All right, so a truck approaches you at an unknown speed. The sound of the truck's engine has a frequency of 210 hertz. However, you hear a frequency of 220 hertz. The speed of sound is 340 meters per second. Question A, calculate the speed of the truck. Alright, well, first things first, ladies and gentlemen. Alright, this is question 3. We have an unknown speed of the truck. We know that the speed of sound is 340 meters per second. The frequency of the listener, we said was 220 hertz. So for FL, 220 hertz. And I think the truck emitted a sound of 210. Alright, perfect. Alright, that's all our information. Now we know our Doppler effect formula. FL is equal to V plus minus VL all over V plus minus Vs. Right? We put brackets around there times F of S. Okay, so what we're going to do first, we're going to get rid of Fs there quickly. FL all over Fs is equal to, now we know that the velocity of the listener was 0. Right? He's not moving. V, alright, all over V. Alright, let's have a look at the question. The truck approaches you, and when the truck approaches and when the source moves towards the listener, alright, then that means it's a negative speed. So therefore it's minus Vs. Okay, now this is our unknown. This is our unknown. So what we're going to do, so we have to rearrange our formula. Okay, and so what we're going to do is on this side, we're going to multiply by V minus Vs to get rid of this fraction. And then we're going to multiply it on this side as well. Alright, there we go. Then we're going to multiply by Fs on this side to cancel the fraction. And we're going to multiply the side by F of S as well. So V minus Vs, all brackets, times F of L equals V times F of S. Alright, then what we're going to do is we're going to divide this side by F of L. So we're going to divide that side, then we're going to divide this side by F of L. Alright, then we're going to divide this side by V to get rid of the V, and then we're going to divide this side by V as well. So therefore, V minus Vs over V is equal to the frequency of sound over the frequency of the listener. Alright, now what can we see on this side over here? We have V minus Vs over V. So if we split this fraction up over here, we have V over V minus Vs over V equals Fs over Fl. Alright, let's actually make that clearer for everybody. There we go. There we go. So then we have 1 minus Vs over V equals Fs over Fl. Alright. And that was pretty simple. Okay. So what we want to do is we want to keep the negative all on this. We want to keep Vs and V on this side. Okay. So what we will do is we'll take the 1 minus Fs over Fl equals Vs over V, which is the same as saying Vs over V equals 1 minus Fs over Fl. Okay? Then, what we're going to do is, now that we have that, alright, what we're going to do is we're going to get rid of the V. So, therefore, we have Vs is going to equal to V, brackets, 1 minus Fs over F of L. Right? Which equals to, we know what V was equal to, 340. 1 minus frequency of the sound source was 210 over 220. All right, and if we put that in on our calculator, therefore Vs is equal to 15.5 meters per second. All right, that was 3a. All right, perfect. And that's how we calculate that, okay? Please understand and watch the step when you have to get what you are looking for at the bottom. On top, you have to cross multiply to rearrange the formula, okay? You can simply just flip it, of course, which makes sense, but we have to show the maths, otherwise the marker will not understand what we are doing. All right, if this still seems a little bit intricate to you, all right, what we can do is just rewind the video and watch the explanations, as well as write down what I've written down on the board to help you understand it a little bit clearer. All right, B, how will the sound change as the truck passes you? Explain the phenomenon in terms of wavelength and frequency of sound. Well, we know that as the truck passes you, okay, what happens to the frequency? All right, the frequency begins to get, because the frequency gets to be lower, it decreases. So what happens to the frequency? Okay, the frequency goes from high or higher to lower. All right, and what happens to the wavelengths? Because if they're shorter wavelengths, there's higher frequency. All right, so therefore the wavelength of the sound that's being emitted, the wavelength becomes longer. All right, because the truck is going further and further and further away from you. Okay, and that wraps up the section on Doppler effect. Thank you very much, ladies and gentlemen. I hope you have enjoyed this section with me, as I've enjoyed teaching it to you as well.